Okay, so this is my lab setup for the lab Bullseye, and I've got my track, and I have taped it right over here. I've taped it to a surface, and I've allowed it to kind of incline down. I've got some distance measurements for there from our previous lab, but you don't really need that. You just need a consistent spot that you can drop from. So I'm just going to choose to drop it from that spot right there. Again, just mark where you're going to drop it from. And then I have taped it down here. And one of the key things for this lab is that you have to have the ball or the marble launch horizontally. So I have taped it right here to make sure that this part is horizontal so that when it flies off horizontally. And I've got my photo gate attached to my digital adapter attached to the SparkLink Air, and then the SparkLink Air is plugged in my computer. Another key thing for this lab is you have to measure the velocity of the marble as it flies off. And so remember that you need to make sure that this part of the photo gate is measuring the diameter of the ball. So that's a little tricky. You may need to adjust the height of your track or lower the photo gate to make sure that the laser that's going through here is measuring the diameter of the ball as it flies off, okay? So now I'm gonna walk through the setup of the software for this. Okay, so when you go to plug in your digital adapter, you're going to go ahead and select sensor data. And you are going to need to configure the digital adapter. So remember, we've done this before. You're going to come over here, click configure sensor. And we have one photo gate timing, one photo gate. Okay. And we're going to input the flag length, which is the diameter of the marble. And the diameter of the marble is 0.015 meters. Okay. And again, we want to know what the velocity is. So we're going to uncheck time and select velocity in gate. And we want to go ahead and select our table and graph. And the graph doesn't really do anything for us. We're going to kind of focus here on the table. Remember that you can press start and do all your trials at once, and then press stop, and then the computer will average it for you. I would suggest having like a box or here for the ball to land in, so you're not constantly having to chase the ball. Just kind of have something down here on the floor. And your goal is to get a consistent average velocity. And so I'm going to measure 10 times. So I'm going to run it through 10 times and then average it. So I'll go ahead and press start. And again, you're going to drop it from a consistent height. So for me, that consistent height is right here. And again, you may want to open your track. Remember how when you kind of store it, sometimes it gets a little bent. It's not the highest quality thing, but it's the best I could get you. Okay. Okay. So 10 times from the same height. Here we go. Okay, so I've got some runs and I can see, I want to stop. I can see that I have some pretty consistent values. My first run seems pretty off though. I have this run of 2.18 meters per second, and then the rest are kind of hovering around 1.5. And so when you go to select your statistics, so table properties, and then do the mean, okay, it's going to take that one into account. And the way you can, I think, do this is to select your data and just do the mean of those ones. And then it kind of gets rid of that one. Okay, so I'm going to walk through that again. So you'll select the data you want to average, and then come back here and do your mean. Okay, and that way you don't have that kind of anomaly in your data. For me, it was kind of easy because it was the first one and I didn't have to just highlight it. I believe you can just use the control button and select different ones. Oh, no, you can't. So hopefully your data is good. You can't use the control button. So hopefully you have enough data that you can kind of highlight the ones that you know are good and then do your mean value. Okay, well, maybe, nope, that's all you can do. Okay, so then you're gonna get an average velocity, and that's how you're gonna collect your data. Now, like the crucial thing is that the diameter of the ball is going through this. Otherwise, it's gonna give you a improper velocity value, and that's kind of some error analysis you might have to do on the back end. Okay, so that is how you set up the lab Bullseye.